Okay, so for today's presentation, I'd like to take you through an overview of SOLIDWORKS sustainability. Sustainability is what we call an LCA, life cycle assessment tool. So we're able to define for each component in an assembly what it's made from, where about in the world it's made, and where the country of final usage is. And each stage in the material's life is calculated for its impact on the environment. So right from extracting that material from the earth, right through to end of life and recycling. Our software covers four metrics, the four metrics on screen. So carbon footprint is all that carbon dioxide and methane that's released into the atmosphere, resulting in global warming. Total energy, so all that power that's required for the manufacturing process and causes emissions into the atmosphere. Air acidification, so as a direct result of pollution from burning fossil fuels, we see acid rain. And water eutrophication, so contamination into our streams and rivers and so on. The information that you will see is coming from a company called PE International, part of the Sphera Group. They've been around for a long time, 25 years in life cycle assessment. They're very well known, and they produce the Gabi4 software database. So their database is well known, international, well vetted, and their customers include some of the largest corporations in the world. So we have a very simple interface in SOLIDWORKS for calculating our environmental impact, but there's a lot going on under the hood. There's a huge amount of calculations, and the data used for these comes from the Gabi4 database, and it's been gathered over a long period of time by people visiting factories in different regions throughout the world to take local measurements. Two levels of the tool. The Express tool is available in every SOLIDWORKS, and it's for parts. You have the material selection tool, which I'll use in the demonstration, which allows you to explore a green alternative to the material you're currently using. We have the dashboard, which will keep in focus those four key metrics, so we can see whether our decisions have a positive or a negative effect. And with all levels of the tool, it will create a customizable detail report, so a great deliverable to the end user. Full-blown sustainability includes all that Express functionality, but it allows you to also analyze assemblies. Lots of parts come together during the assembly process, so there may be energy consumption in assembling our design, but also that final design needs to be shipped to the end user. So these things need to be taken into consideration. May also be that we have an element of power for an electrically operated device. It also supports configurations. And as I said, it has some expanded capabilities for things like amount and type of energy consumed during use. We'll also see the assembly visualization tool and how the results can be used alongside that. So let's dip into SOLIDWORKS. And on screen, I have a humidifier assembly. So when figuring out where to start, your assembly visualization tool can be useful for giving you an indication of the ordering of components in your design based on a chosen parameter. So here I've said, well, let's take a look at the value for the carbon footprint, and it's ordering from, I guess, highest impact through to lowest impact, all the different components of my design. So I'm going to take a look at the tank here, water tank. Let's open that up. So first off, I can start by doing an impact assessment on this part. Just give it a click and it starts to give me some values here. So you can see the values for carbon footprint, energy, air acidification, water eutrophication. And if I give these a click, it actually breaks it down into each of the different stages. So material procurement, manufacturing processes, the usage, end of life, and any transportation in between from factory to factory or maybe country to country. So starting at the top, I can pick the material and the material subcategory. This actually inherits that information from the SOLIDWORKS model. So if you already applied it, it will appear here, but you can change it if you like. Working my way down, I can decide where this part is made. Let's imagine this is made in Asia. So this is one of the selectable regions. And it might well be used in a different part of the world. So my part is going to go from Asia, where it's made, to Japan, where it's assembled into the final device. And finally, that gets shipped back to Europe to the end user. So some more information we can put in. Well, firstly, I can say how long this part is perhaps built to last. So it may be a consumable within the full assembly. And you can choose years, months, days, or hours. Also, depending on the manufacturing process, as you can see here, these are relevant to plastics. We can input, or use the default values given where available for the electricity, gas use during that process. And also we can put in here an allowance for any scrappage. We make 10,000 of these. It may be that maybe a few tens or even 100 of those need to be binned because they don't get through Q&A. Under the paint conditions here, if I say no paint, keep an eye on the metrics. Obviously what I'm doing is having a more positive impact on the environment. There's less harmful chemicals and less manufacturing requirement. So you can see I'm having a positive impact shown by the green bar, and the percentage of improvement is shown here too. Obviously choosing the solvent base, which we started with, will ramp that right back up again and have a detrimental impact on the environment. So transporting this from Asia to Japan, it will give me a default value and a default method of shipping and a value for the distance, but I can overwrite and I can add different stages of transport in as applicable. So if I have that further data, I can add that myself. And the end of life for this part, we can put in values for the amount of recyclable content, how much of that goes to be incinerated and what ends up in the landfill. So it's not too bad so far, but what I'd like to do is look at really making this a very environmentally friendly part, or improving upon my environmental impact. So it's quite thick. I'm going to thin it down a bit, but I need to make sure it's still a strong material, or maybe something stronger than the PE low medium density plastic I'm using currently. Because in practice, somebody might put something heavy on the tank and I don't want it to give way. So I need to make sure this is suitable for purpose. So we've got a great tool here called Find Similar, and this will allow me to search for similar materials based on mechanical properties. So I'm looking for another plastic, about the same density, but I want something stronger, so a higher tensile strength. Now, if I hit Find Similar, this will scan the database and immediately give me some feedback. And I can pick or slim down the list to any materials I might be willing to consider as an alternative. And as I select any of these, there you go, it analyzes and shows me their environmental impact compared to the original material. So I'm going to use here the PP Homo Polymer. We'll accept and we'll set material, which will actually set the SolidWorks material property. So it carries that change through. So that's obviously had a positive impact. And as a reminder, we also got rid of that nasty paint finish. So let's go back to the model and let's modify the wall thickness of our design. So currently that's 2.5 mil. Now I've got a stronger material. I'm going to bring it down to 1.5 mil instead. There we go. Now, before I go back and assess the environmental impact, it may be that one of your stages in improving the environmental friendliness of your products is to do a bit of testing. Now, this is obviously something that's purely as an example, but I've actually got a study here set up to simulate what would happen if somebody put something heavy. So a force of 49.05 newtons pushing down upon the top face here, and we've got a pressure inside of the tank as well in use. So this of course gives me an idea of the stress, the amount of movement, but the factor of safety is what I'm interested in. So by reducing that material and performing a test under its assumed low conditions, we're verifying there in a virtual world that we've still got a factor of safety of 2.1. So we should be able to carry 2.1 times the applied load before failure. So it's pretty safe actually, this part. So now I'm happy with that. We've got the option to go back to the sustainability tools. There we go. Give that a second just to update. And we can see we've got some big improvements there. So we've made this about 50%. We've reduced the environmental impact for each of these metrics by about 50%. So not bad going at all. So at this stage, we can output a report. So we'll save the information out, and you can do that as a Word document or a sort of spreadsheet or what we call a Gabby input file. So this could actually be passed on to some further software for further analysis. Give it a name, tell it where to put it. So let's call this the tank sustainability report. We'll OK that. In fact, let's just pop that on the desktop. And we'll give it just a moment or two to create. Okay, so it's produced that report for us, and because it's a Word-based template, you can fully customize it with your company logo, company information, but it's using this to very quickly gather that information and put it in a nice end-user facing report. So it gives me a breakdown of all the options that we've put in, and as you can see, we have a copy of those 4 key metrics. So our carbon footprint value, energy consumption, air acidification, water purification. Back in SolidWorks, we'll give that a save, just commit to those changes, and we'll nip back into the assembly. So we'll take a look at the sustainability options here. We have, for instance, the option to decide where we assemble all the parts. So as I mentioned before, this will be Japan, how long this design is built to last. But also you can include energy required in the assembly process. So that might be electricity, maybe natural gas. So I've specified a value for that in kilowatt hours. The final usage, it's shipped off to Europe once assembled. And of course, it's an electrically powered device. So we might put in here as well an amount of electricity used. So if I just assume a value there for kilowatt hours per year, so we can specify that right down to an hourly rate. Shipping is included here with a sort of default value for sea freight from Japan to Europe, but that's fully editable. And you'll see at the bottom here, at the bottom there, oh, there we go, we've got end of life. So what percentage of this product has recyclability, what needs to be incinerated, and what will end up in the landfill. These are editable. It's taken this information. There we go. So we can sort of reset some defaults, but it's taken that information from all the inputs I've put in. So once done, we can save that out again as a report. We'll just make sure we have Word closed down. And this, of course, gives me the assembly report. So we've got the humidifier assembly. Again, just pop that on the desktop and give that a moment or two to create. Okay, so that's just popped up. There we go. So now we're looking at the assembly analysis. So again, an indication of what options and what information has been put in by the user, but also the footprints, I guess, the impact dashboard, and a breakdown for each of the component parts and what impact each of those has on the environment for those 4 measured metrics. You'll see in the reports and the software, little blue hyperlink. What that is a link to some online information. There's a SolidWorks sustainability website, and we can input the values for each of those metrics into the system, maybe comparing the original design base to our sort of improved design. And it gives us some more understandable or easier to understand metrics. So energy consumption, what does that really mean? Well, it might be like watching 3 hours of TV, or 18 hours powering a light bulb, or 31 hours powering up your laptop. That value may be for the carbon footprint, 34 miles driving a European car, 31 in a US car, but 70 miles if that were a hybrid. It's just different ways of looking at the information just to make that easier for the end user to understand. So that's our SOLIDWORKS sustainability tool for life cycle assessment.